Good morning students, my name is Ejri Babu, working as Assistant Professor in Department of Civil in Pace Institute of Technology and Sciences. I am going to give the lecture on design and drawing of steel structures, that means DDSS, design and drawing of steel structures. Now I would like to give the introduction about the DDSS, design and drawing of steel structures. So first, if we go for the introduction, we need to know the few things. So that is, first is steel structure. So first we have to know about the steel structures. First we have to know how the steel will come. For example, so many iron ores are there in the world. So from the iron ores, iron is available. We have to take the iron, then we have to melt that iron, so it will form like a liquid type. Then if we add the carbon, then that iron will transform to steel. If we add the carbon percentage more, automatically iron steel strength also will get more. So that is, the steel will come from the iron ores. So that is the steel. Here the steel structure means, so from the steel, different shapes of steel sections are available at outside. So if that all sections connecting together, that is, we will call it as a steel structures. That is about the steel structures. For example, if you see the common types of steel structures, for example, in the world, rapidly it is growing that steel structure when compared to concrete structures. That steel structures, for example, if you see the airport, maximum airports, that platforms and everything is only we have to do it by the steel only. And then railway stations also, railway station platforms also we have to construct by steel only. And then for example, towers, any steel towers also there, that also steel structures. And any factories, cinema halls, auditoriums, theaters, so everything we have to do it by the steel structure. These are all the common types of steel structures. And next we have to know about why we have to prefer the steel structure when compared to concrete structures. That means, what are the merits and demerits of the steel structures. Compare it to concrete structures. See, that means reinforced concrete structures, RCS. Merits and demerits of steel structures compared to reinforced concrete structures. We have so many advantages for the steel structures when compared to reinforced concrete structures. Why? Because if you see the merits of the steel structures, the first one is speedy construction is possible. For example, this is the merits. Speedy construction is possible. Why speedy construction means, if you see the concrete structures, what we have to do? So first, for example, if we construct the slab in the reinforced concrete structures, what we have to do? So first we have to do the scaffolding. After scaffolding, we have to arrange the formwork for the slab. After formwork, what we have to do? First we have to place the steel reinforcement, and later we have to pour the concrete, and then later we have, after some time, we have to do the curing, and later we have to remove the formwork and scaffolding, everything. It takes a lot of time. So it may take around weeks, okay, 1 week or 2 weeks or 3 weeks also there. That is taking more time. But if we do the steel structures, different types of sections already available in the market. For example, beams already available, columns, steel columns already available. So different types of sections are already available. So we can take the directly whatever the length we need, so we can take it directly from the market, then we have to place it. So we have to directly take that precast steel structure, we have to keep it, and then we have to connect by bolt or rivet or any welding. So directly take the section and keep it, simply place it, that is enough. Simply it is very speedy construction is possible when compared to concrete structures. So that is the one main advantage of the steel structure. And then the second thing is dismantling and reuse. Reuse also possible. Dismantling and reuse means, for example, if any concrete structure is there, if any failure will come, what you have to do? For example, slowly some cracks are happening. So what we can do something, tie it. For example, if any cracks are there, so in that cracks we have to take some cement, concrete, then we have to fill that gaps. That is actually we will do. For example, in the dismantling and reuse means, if I take any land, okay, for some, I will take the land for the lease, okay, I will construct one theatre, I will construct any theatre, any auditorium for some period. So in that time, if we do the concrete structures for that particular period, after that lease time is over, so for the concrete everything is spoiled, okay, so my money, everything we cannot get it later, finish that lease time, okay, we cannot use anything after a collapse of that structure. For example, if we take the steel structure, every element, for example, these columns and then these beams, everything we can dismantling, and then we can go there wherever you want to do the construction, then we can use this steel structure. Why? Because steel, we cannot spoil that steel, okay, but concrete structures, how we can break? We have to break the walls, we have to break the beams, we have to break the slab, everything. So it is a lot of time, and then so much money also waste, but simply dismantle, and then we have to go wherever we need. Again, these structural members we can use it somewhere for another structure. So that is the main advantage of the merits in the steel structure. And next one, third one is, it can lifetime also more. It is more durability. When compared to concrete, the steel, it takes more load. It takes more load, and then lifetime also more when compared to concrete structures. These are the common advantages of the steel structure, but some disadvantages also there. For example, the disadvantage is demerits. The main disadvantage of the steel structure is, one is the corrosion. Corrosion will happen. That is only the main problem. If the corrosion will happen, the slowly the structure also little bit failure also will come. So that is the one of the main problem. But we can rectify this corrosion by applying some paints. Okay, that is not a major problem, but little bit this also we have to consider in the demerit. That is the one is the corrosion, and second thing is temperature stresses. Temperature stresses high. Temperature stresses means, due to the climatic changes, rainy season and in summer, mainly this is steel, na? So in the steel structures more heat will generate. So due to the more heat in the steel structure, internally some stresses will generate. Due to that stresses, so little bit failure will be happen in the steel structures. So that is the temperature stresses. That is also one of the demerit in the steel structures. And next one, third one is the maintenance problem. maintenance problems also will be happen. Maintenance problems means what? For example, after construction is over, steel structure construction is over, then sometimes the connections may get loose. Okay, so if we will not take serious about that connections, the total structure also may get damaged. So we have to continuously check that structure. If any joints will get loose, immediately we have to tight the joints. So that is the maintenance problems also will be happen. So continuously we have to check our structure. These are the generally advantages and disadvantages of the steel structures. And next one, if you see that merits and demerits is over, next one is the rolled steel sections. Rolled steel sections means rolled means it is a one mold type. For example, if you take a cube 150 into 150 into 150 mm cube, that is the mold. In that mold we have to keep the concrete. After remove the mold, then concrete cube we will get it. The same way, rolled means here different types of sections are there. What are the different types of sections? I sections also there. Okay, and then channel sections also there. Next, angle sections also there, and then T sections also there. Different types of sections are there. This I sections mold is already available. So in that I section mold, we have to keep the that liquid. Then after some time, it may get hard. Then we have to remove the mold. Then totally I section we will get it. That is the rolled. That is the meaning of rolled. So rolled steel sections means we have different sections are already available. Okay, in these different sections also, some small sizes and then some larger sizes. So different properties of I sections also available. For example, we will call it as different names in the I section. For example, I, S, L, B, I, S, J, B, ISJB, JB, for example. This means ISLB, Indian Standard Light Beam, Indian Standard Light Beam. Next, Indian Standard Junior Beam. Same way, channel also there, and more is also available. Just for the reference, I have mentioned only two. And next one, channel also. Channel means ISLC, ISJC. Okay, so like that, different names we can call it this I section. What it is ISLB, what it is ISJB? If we go for ISLB, Indian Standard Light Beam, that properties are different. That properties means what? For example, if we take the I section, this is the I section. Okay, this is the breadth of the flange. Okay, this is the overall height. This is the depth of the flange. This one is the breadth of the web. Breadth of the web. Okay, these are all are the properties. Okay, height is different, breadth of flange is different, breadth of web is different, depth of flange also different. These all properties are may change in junior beam. And then if you go for another, for example, Indian Standard ISHB, this means what? Indian Standard Heavy Beam. If you go for Indian Standard Heavy Beam, that properties also may get changed. That means what? Some dimensions also may get changed. Center of gravity also may get changed. Okay, so like that, depth also may get changed. Breadth of flange also may get changed. So different types of I sections are available in the market. Okay, and next one, channel also there. Channel also, different types of channels are available. Channel means, for example, this one. This is the channel section. This is also breadth of the flange. This is the height, and then this is the breadth of the web, and then this is the breadth of the thickness of the depth of the flange or thickness of the flange. This is also there. So Indian Standard Light Channel, Indian Standard junior channel. So like that, different types of channels also there. If you go for another channel, that properties also may get changed. Whatever the suction we need, that section only we have to take it. That is about the ISJC. So same way, angle sections also there. Angle sections means IS Indian Standard Angle, we can call it as ISA, and then next one 150 into 150 into 10, for example 15, for example 150 15 means what? For example, this is the L section. This is the L section. 150 means what? This is the 150, okay, mm, and next one this is also 150 mm. This 15 means was this thickness. This is the thickness. So this is about, so 150 into 15 mm. So like that, different types of different types of angle sections also available in the market. Whatever the section we need, we have to take it. That is about the Indian Standard Angle section. Same way, T sections also there. Indian Standard T sections. So T, for example, this is the T. This is the breadth of the flange, thickness of the flange. This is the overall height, and then thickness of the web. IST, Indian Standard T sections. So like that, different types of T sections also available. Whatever the properties of section is required to us. For example, if we place a beam, so for that beam, whatever the beam is required, whatever the properties of beam is required, so that beam we have to take it and we have to place it. That is about the different types of rolled steel sections. And later loads. In that loads, we have different types of loads will act on the steel structure. What are the different types of loads? One is the dead load. First one is the dead load. Second one is the live load. And third one is the wind load. And next fourth one is the snow load. So like that, different types of loads are there. Why we have to consider these loads? For example, if we construct any steel structure means, for example, this is the steel structure, okay, steel structure, any structure. Here dead load means what? Dead load means, for example, this is the column, beam, okay, so this frame, everything, this truss, for example, this truss, whatever the structural elements load, how much the load of that steel structural element, that element's load we can call it as dead load. For example, dead load is the permanent load, we cannot change that one. But in the live load is the temporary load. For example, if we take a railway platform, railway bridge, okay, the train will go in this side, so this is the walking, so this is the railway, this is the train passage, this one is the going to that side bridge, okay. Here people also may get walk, this means what? Going this side and getting down on that side. This is the people are walking, that means what? We can take it as, that is temporary load, live load, we have to take it. Means whatever the temporary loads are there, for example, in the building, any benches or any tables, okay, everything we have to, whatever the temporary parts are there, that is also we have to consider the load, that is the live load. So dead load is the permanent load, wind load is the live load is the temporary load. And then if we go for the wind load, see, for example, this is one steel structure. For example, this is the window, and then this is the door, okay. Here this is what? any window, this is also window, okay, this is the door. We have to take very serious about the wind load. Why? Because there is separate code book also there for the wind load. We have to use that code book. Why we have to take very serious about wind load? See, if we see this structure, the wind will come and then it will enter through these windows, through this entrance, okay, door. So wherever the openings are there, from that all openings the wind will come inside and then it will rotate, and what will happen, finally it will go up and hit the truss. So that's why sometimes whatever the that roof means concrete roof, asbestos sheet roof, galvanized iron sheet, sometimes in the during the heavy wind, what will happen, they may get some sound, top roof. Sometimes that roof part also may go somewhere, maybe get broken. Why? Because that is problem will occur due to the wind only. The all wind will come inside, will rotate, there is no space to go outside. Why? Because wind is coming this side, on that direction again it will not possible to go back. Why? Because it is coming, entrance it is coming, but there is no space. So what will happen on the time, the whole wind will rotate and hit the top side. So that's why finally failure will occur at the truss, and the roof also may get fail. So that's why we have to take very serious about the wind load. And next one is the snow load. Snow load also we have to take very serious. Why? Because in Andhra, Telangana, it is not much snow will happen. Okay, but if you go for the North India, Jammu Kashmir, so at that places definitely we have to consider the snow load. Why? Because the snow will place over the roof. Snow will store over the roof. Okay, whatever the sometimes if you see the bridges also, whatever the snow will come, it will accumulate here. So we have to consider this load also. We have to consider. Means while we design the steel structure, we have to consider the dead load, we have to consider the live load, and then we have to consider the wind load. If it is necessary, we have to consider the snow loads. And the last one is the earthquake load. In this earthquake load, this is also we have to consider. Due to the tectonic plates moving, what will happen at the bottom, due to the tectonic plates moving, these columns also may get problem. Okay, that is due to the earthquake only. So we have to consider that earthquake load also. So we have to consider this all the loads, then only we have to design the structures. Sometimes combination loads also there, we have to consider combination of loads. The combination of loads means what? Dead load plus live load. Dead load plus live load. And next one, second one is the dead load plus live load plus wind load. So like that combination of loads also we have to take as per as our requirement. Okay, that particular city, if it is required, then we have to consider these three loads combination and then these two loads combination, like that. Sometimes snow load also there. This is the loads and then load combination. And next one, we have to remember one thing. For example, how we have to means what are the things that we have to consider, how we have to place a beam. For example, load is coming. For that load, for example, if we take this one, this is the truss and roof, this part is the roof. Okay, this whole load is coming to this beam. So first I have to design this beam. How I have to design this beam? Whatever the top dead load, live load and wind load, if it is required the snow load, the whole load will comes to this beam. This beam we can take it as generally I sections, generally we can use it for the beams or columns. So this thicker part is the beam. Okay, so this beam we have to design. How we have to design? First we have to consider the load. How much load is coming? For example, something 50 or 60 kilonewton something load is coming, that uniformly distributed load is coming. As per, first we have to consider the load, and after that to resist that load, which type of beam is suitable to resist the top load. I already told you, I sections, number of I sections are there. That is what? IS, JB, IS, HB, IS, LB. These all number of I sections are there. So which I section I have to use? I told you already, different beams, different properties, different types of beams, they have the different properties. So whatever the beam is exactly will resist, whatever the beam is fit. So first, so that's why we can do it one thing, you can take it any one beam. Before we place the beam, so first we have to check this beam is safe or not. So we have to check it in the shear part, in the deflection and in the bending. If it is not suitable, then we have to take another beam. So like that we have to select the beam or column, whatever it may be. So we have to first take any one column. If it is fit or not, we have to check it before we place. If it is safe, then we can go for the next one. Okay, and next later we need to know one thing, that is the factor of safety. We need to know the factor of safety. This factor of safety, for example, for simply understanding, I constructed one slab. For example, this beam is there. Okay, otherwise one slab is there. This is a slab. Okay, and another staircase also there here. This is a slab. The slab capacity maximum 100 people, 100 students. For example, this is the any college. This slab capacity 100 only. That means what? If we keep the chairs, only 100 students, only this slab can bear. That is actually the construction. But what I will do is, the slab, it is, I will design this beam for 150. Actually 100 is enough, but I will design this beam is 150. Why 150? I design this beam is 150. I will tell to the people capacity is only 100. Okay, so if 100 people will come, no problem. But if it cross the, for example, but I designed in 150 in my mind. For example, if any function is there, 110 members came. Capacity is 100, but I designed 150, but I told to them that is only 100. But 110 came, no, not at all any problem. 120, not a problem. 130, not a problem. Okay, so I remembered one factor, I applied that factor, that is for safety factor, that is we call it as factor of safety. Okay, but this capacity is 100, I designed this beam also 100, I designed this slab also 100, then if any case, worst case, 150, 120, 130 students also may come. So in that cases, this slab may not bear, definitely it may get collapse. So that's why it is very, very important, we need to consider the factor. That factor means we tell to that owner that capacity is 100, but we designed for 150. Okay, whatever that factor, that is safety purpose, that is the factor of safety. This factor of safety definitely we have to consider for any type of structure. Even in the concrete structures also we have to consider, and for the steel structures also definitely we have to consider the factor of safety. This is about the factor of safety. And next one we need to remember, for this purpose mainly here we have to use the limit state method. Actually two types of methods are there. One is the working stress method, next limit state method. Working stress method, limit state method is, working stress method is the old method. Okay, if I construct the working stress method, here in the working stress method main problem is actually no advanced method is the limit state method. Okay, outside whatever the construction is going on, maximum they are doing their construction by using limit state method only. Any steel structure they are doing by limit state method only. This is advanced method. Why not working stress method? Working stress method, it is not fulfilled if any, for example they designed they constructed any one steel structure, after long period whatever the problems will come, it is not satisfying in this working stress method. That problems, it is not controlled, problems not controlled, the problem is going get increase. Okay, that is the main problem in the working stress method. But in the limit state method, after steel structure, one structure it is designed, construction is over, after long period whatever the problems will come, that problems also withstand, okay, by applying some factor. So that is the main advantage in the limit state method. But working stress method is failed. It is not failed. In the olden days maximum all structures are the working stress method only, but an advanced method is the limit state method. But if we go for the working stress method, in future whatever the problems will come in the structure not resist. Okay, why? Because that resistance is not considered in this working stress method, but in the limit state method that factor is considered. Okay, that factor of safety we will apply. Whatever the problems will come, the deflections and cracking, vibrations, whatever the problems will come, all the problems we can solve by using the limit state method. Okay, and then next thing we have to remember another thing also. Different types of connections are there. We already understood what is steel structure, what are the common types of steel structures, what are the advantages and disadvantages, everything already we heard. And next one, connections also very important. Connections are joints. Connections are joints. This means, for example, this is one column, this is one column. Here this both connection is very important. This both connection is very important. And then this is the roof truss. This connection also very important. At bottom this connection also important, this connection also important. Actually in the concrete structures what we will do, for example, if any beam is there, okay, simply we have to make the formwork, then reinforcement we have to keep it, place the concrete and do the compaction, and later curing everything will be there. And then if you do the slab, this part, this reinforcement will go top and then come this side, and then same wise this slab reinforcement also will come this side. So this is the joint part. Reinforcement will continue and enter into the slab. Sometimes this reinforcement will go up if any stair also there. Okay, that is the joint. For concrete it's not a problem, but for this steel connections are very very important. If connections are fail, then whole structure also may get damaged. So here we have to consider definitely connections. That connections are three types of connections we have. One is the welded connection, next second one is the bolted connection, next third one is the riveted connections. Riveted connections. So here if you see these welded connections, welded means we have one electric arc, so by using that arc one weld metal also there, by using that weld metal the both elements, both structural elements, by welding we can make the joint. That is about the welded joint. Okay. Next one is the bolting. Bolting, here if you see the welded joints, for example this is the one plate, okay, this one is another plate, we have to join this by using this welding. Okay, this is about the welding. If you see the bolting, second one, how we have to do the bolt? So first this is the one plate, I have to joint another plate. Okay, I have to joint another plate. We have to make a hole here, and by using bolt and nut through this hole, and then here to this bolt one nut also there. We have to fix one nut, tight that. So that is about the bolting. So connections, the joints we have to do by using bolting also one method. And next one is the riveting. Riveting means, for example, this is one plate, one element, and second one is the one element. We have to make a joint, we have to tie this joint by using riveting. How we have to do? So first we have to make a hole first, and then after that one riveting connections, riveting metals are there, that metals, so we have to send one riveting metal, same like a bolt type. After it is coming, by using hammer we have to hit at the bottom, so what will happen? This one will form like that. Okay, this is about the riveting. Okay, these are the three types of connections are there: welded connections, and then bolted connections. Next one is the riveted connections. Welded connections means simply we have to do the welding by using electric arc and then weld metal. So this is about the welding. And next one, second one is the bolting. We have to make a hole, send the bolt and tie by using nut. And next one is the riveted connection. We have to make the hole, send the rivet metal, okay, at the bottom we have to hit and then tie it. That is about the riveted connections. These are the three types of connections. If you see the welding in clear, for example, for the welding also some advantages and some disadvantages also there when compared to riveted connections. So if we see the clear picture about the welding, welding also different types of welds are there. Okay. Types of welding. So one is the fillet weld, second one is the butt weld, okay. Next one is the slot weld. These are the three types of welding are there. So in the fillet weld, I will give one structure. For example, this is one beam and then this is another beam element, we have to connect this total. This is the fillet weld. And next one, butt weld. Butt weld means this is one structural element, second one also one structural element. We have to joint these two structural element by using welding like that. But in the fillet weld, what you have to do? We have to do the overlap, then do the welding. But in the butt weld, keep this side by side, then make welding. Next, slot weld. Slot weld means, for example, this is one plate. Okay, we have to connect another plate like that. So we have to make a hole first here. We have to make a hole. In that hole, we have to fill the welding metal. Okay, so like that we have to make the connection. Okay, that is the slot or plug weld. These are the three types of the fillet weld. That is, one is the fillet weld. Fillet weld means simply overlapping and then doing welding. Butt weld means side by side. Slot weld means we have to make a hole. In that hole we have to pour the welding metal, then the both will get tight. That is about the slot weld, fillet weld, butt weld and slot weld. And then if we go for the advantages and disadvantages of welding, compare it to riveted. Some of the advantages also there, some of the disadvantages also there for the welding. Here for the welding merits, if you see the merits, in the welding part mainly the merit mean it is speedy construction also possible. Okay, by using welding, simply wherever the joint we need to do it, simply we can make by using welding. So speedy it will complete. And then second thing here, more strength. It will get the high strength when compared to riveting. And then the third one, lightweight. Okay, welding lightweight also, maybe that welding metal also it is weight is very less, so that the whole structure also lightweight. These are the merits of the welding. If we do the demerits when compared to riveting, it is total structure weight also may get increase. Why? Structure weight is high. Why? Because for example, if you use the riveting, again we need some elements. If you use the bolt, again we need some bolt and nuts. Okay, already our structure have some weightage. If we use again the riveting metals and then bolting metals, weight also may get increased. That is one of the main problem. Okay, and then that is the one demerit. And second thing is the inspection problems. Inspection during maintenance. This means, for example, if any problem is happening, it is very difficult to do the inspection. Why? Because while we are doing welding, we have to take very serious all the part is filling or not. Okay, all the part is filling or not. While we are doing the welding, if any little bit gaps are also there, due to that gaps may form like a cracks. That cracks may affect the whole structure. Okay, if finally if any problem will come, so definitely that is because of the that holes only. So that inspection also very difficult to check the where the holes are there, where the holes are there. So is it everything is covered or not? So that is inspection during the maintenance. This is also one of the main problem. And then if we go for one more advantage here, this is no sound will produce, but it is high sound will come. What no sound and what high sound means? For example, if we go for the merits, if you do the welding, even if any problem will come, they may not get any sound. Okay. For example, here in the demerit means high sound will produce. What high sound means? If any bridges are there, steel bridges are there, while vehicle is going on, for after some period, after long period, the bolts may get loose. The bolts may get loose. Due to the losing of the bolts, what will happen? Due to the vehicle is going on the bridge, the whole structure may get some sound. Okay, that is one of the main disadvantage of the bolt and riveting. These are the advantages and disadvantages. And finally, we have in the steel structures several elements we have to design. That is, one is the beams we have to design, second one is the columns we have to design, next one is the purlins we have to design, and next one is the foundation part. Foundation part means base plate also we have to design. Okay, base plate means this is the concrete first foundation. Actually for the concrete structures what we have to do, so first one concrete bed we have to place, and later one mesh, steel mesh we have to provide, and later column will come, then first footing, second footing, and then like that will continue. But here in the steel structure, one concrete bed we have to first in the foundation we have to arrange, later we have to place one base plate. After the base plate, the column section will come, and then we have to connect the by using bolts. Okay, this is the base plate. So base plate design also we have, slab base or base plate design also we have, and later next one is the plate girder, gantry girder and gantry girder. So plate girders and gantry girders also design also we have. For this all designs, and then first welding also there, and then bolting also there, then riveting also there. For this all, some guidelines are there. Okay, for that purpose we have one code book. That code book is IS 800/2007. Okay, by using this code book we have to design this all, everything, how much welding we have to provide, how much overlap we have to do it, okay, which type of sections is suitable. So everything, beams, columns, purlins, base plate, plate girder, gantry girder, everything we have to use that IS 800/2007. And then we need one steel table also required for the design. Steel table. What is the main use of the steel table means, in that steel table already I told you number of I sections already that with the properties that is available, I sections, channel sections, T sections. So like that number of sections already available in the steel table. Whatever the section we need, we can take it from the steel table. So for that purpose steel table also we need. For the steel we need to remember to solve the beams, columns and base plate, purlins and then plate girder and everything. And different code books also there. For purlin also one more code book also there. For why? Because due to the wind load, definitely the structure may get fail. So for that purpose, for purlins also another code book also we have. So like that we need the code books. With that code books we have to design the whole steel structure. So this is about the simply introduction and then welding. of the steel structures. Okay, I hope you all understood about this one. If any doubts, just you may ask that. Thank you so much.